do a quick example of finding the derivative function of our function f of x equals x squared minus 4x plus 3. So we have here f prime, which is the derivative. The derivative of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And when we want to find the derivative function, all we're going to do is we're going to just evaluate our two functions here, subtract them, divide it by h, and apply the limit. Sounds really easy, right? So let's start with this. So we're always going to make sure we write our limit in the front. Our limit is h approaches 0 of f of x plus h. So everywhere we have an x, we replace it with x plus h. So we have a nice fraction here. It's going to be x plus h squared minus 4 times x plus h plus 3 minus our function f of x, which is this. And since we're subtracting a function with multiple terms, we're going to put parentheses here so that negative distributes to each term later on. So minus the quantity x squared minus 4x plus 3, all divided by h. This is going to equal the limit. I'm just going to simplify this as h approaches 0. And let's do up some of our math here. X plus h squared is going to be x squared plus 2xh plus h squared minus 4x minus 4h. We got to make sure we distribute that negative there. Plus 3, and we're going to distribute the negative here, minus x squared plus 4x minus 3 all over h. Now, you'll notice we have quite a few terms here that in a subtractor cancel out here. We have our x squared and our negative x squared. We have a negative 4x, positive 4x. We have a positive 3 and a negative 3. So those are all going to cancel out, bump, 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 bump with each other. So we're going to be left with here the limit, equals the limit as h approaches 0 of, and we're left here with 2xh plus h squared minus 4h all over h. Now if you've done this right, you'll notice that each term in our numerator has an h. Get an h in the denominator, so let's factor that out and get rid of it. So the limit as h approaches 0 of h times, we're left with 2x plus h minus 4 all over h, and our h's here divide out. And we're going to be left with the limit as h approaches 0 of 2x plus h minus 4. And now, well, we don't have an h in the denominator anymore. That's gone. So we can just use direct substitution for h is going to be equal to 0 here. And now we're evaluating the limit. We don't need to write the limit in the front anymore. And we just get 2x minus 4. So f prime of x is 2x minus 4. So what this has done is we had this function up here originally, f of x equals x squared minus 4x plus 3. And now we have the derivative of that, f prime of x equals 2x minus 4. And if we want, we can use this function to find the slope of the tangent line to our original function at any point on that function.